I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Our adventure today starts with the actual real concept of algebra. Today you will have some one-step equations. One-step equations sound easy because they have one step. Within the next week, you'll have some two-step equations, you'll have some three-step, and we might even get to a four-step equation. But first, let's talk about the one-step equations. This is solving one-step equations. It's Algebra 1, SSE, A1. Interpret the contextual meaning of individual terms and factors from a given problem that utilizes formulas or expressions. Before we can get to an expression, we actually have to have a few things. It says you can represent constraints and equations by inequalities in a system of equations and inequalities and interpret the data points. Before we get to those data points, you need something. I've been running about 3 minutes. I haven't seen an equation on, but today I can solve one-step equations. Try that, put an S in there, using operations on both sides. Now, this is an equation. How do I know it's an equation? It's got an equal sign. Does it have a real number, a constant of some sort? Yes, it's got two of them. It's got 7, it's got 33. Those are numbers. I have an equal sign, I have numbers, and I have a variable. I have X. Your book likes A, B, C. I like X, Y, and Z. Most of the time on a test that I'm going to give you, it will be an X. X is a variable. What is it? You don't know what it is. Can you solve it? Maybe so. Now we talk about algebra like it's different. So let's insert something that you might understand. Table plus 4 equals 5. And sometimes you had this in kindergarten, didn't you? Square plus 4 equal 5. Circle plus 4 equal 5. Triangle plus 4 equal 5. How many of you already know that that's 1? Thank you. Thank you. Raise your hand. Thank you. Hey, now what am I going to do? I'm going to get rid of my box. I'm going to get rid of my rectangle. You had whole kindergarten workbooks that were full of rectangle plus 3 equal 4. Now I'm going to replace it with X. Please don't panic. It's still something you've learned in kindergarten. X, some unknown variable, plus 4, a constant we know about, equal 5, another number we know about. So that's the whole purpose there of the algebra. Here's the most important theorem within algebra. One of those teeter-totters is not a lot of fun. That big bulky boy down there, he ain't moving. Probably get 3 kids on that teeter-totter, and you might not move them. Some of you had that experience. You found a really big boy on the playground who kept you up in the air all period. Not much fun. This is the most important theorem in algebra. This is balance. You can do anything to one side of the equation, and there are 2 sides. If there's an equal sign, there's got to be 2 sides. We'll call it right and left. Whatever you do on the right, you got to do on the left. Whatever you do on the left, you got to do on the right. Now let's look at my sample equations. Here's the big concept. I ask people all the time when we're solving algebra and algebra 2, what are we doing to x? Right now, you only know a couple of things we can do to x. You can add, subtract, multiply, and divide something to x. Look at this problem. Ask yourself, what are we doing to x? I have the answer over here. What are we doing to x? We're adding 7. We're adding 7 to x. Then ask yourself, what's the opposite of adding 7? Over here, I told you it's subtract 7. And once again, it says both sides. If you go up here, you've got to be balanced. No one wants to be on the teeter-totter with him. So if we add 7 over here, we add 7 over here. If we subtract 7 over here, we subtract 7 over here. If we multiply by 5 over here, we multiply by 5 over here. Let's go back to that equation. What did I do? I subtracted 7 from both sides. And I know some of you can leave out this step, but right now I'd like to put in all the steps so that everybody at home and in class makes sure I know what I'm doing. What did I do? I subtracted 7 from that side and from that side. Then what did I do? Then I did the arithmetic. 7 plus 7 is 0, so the x comes down because x plus 0 is still x. And in 33 subtract 7, I got 26. I make hundreds of mistakes a week in mathematics. Sometimes it's a mistake that I made deliberately to see if you're catching on. And sometimes in my mind, I remember in the write-up the student who put his head down, and for a split second, my math was a little bit off. If I did 33 subtract 7 and came out with 22, I would expect somebody in the class to ask me where the 22 came from. Because it can't be, it has to be 26. Let's take a look at a subtraction problem. I told you, you can add, subtract, multiply, and divide, so now we'll subtract. What are we doing to x? We're subtracting 7. It's right there, you can see it. We're subtracting 7. We're taking x and subtracting 7. So how do you undo that? You add 7 to both sides. Add 7 here, add 7 here. Once again, we want our teeter-totter balanced. If you were looking at an old scale in science class, we want it balanced. You don't need this, and you don't need this. We want this. They have to be balanced to work the equation. So the opposite of subtract 7 is add 7, add 7. Then I do the arithmetic. Minus 7 plus 7 is x with a 0. That's an x. X plus 0 is x. And 23 plus 7, of course, is 30. Now, I told you you could add, you could subtract, you could multiply, divide. Here we're going to divide by 7. X divided by 7. That slash, by the way, means divide. I don't like the long division sign. And the word processor really doesn't like x above 7, so that slash means divide. What's the opposite of divide by 7? Multiply by 7. Am I going to do it one side or two? I'm going to do it both sides every time. We always do it both sides. So when I multiply this by 7, and I multiply this side by 7, now I go back to this side, the 7 should cancel out. 7 divided by 7 is 1, 1x. 2 times 7 is 14. We've solved that one. Now, multiplying by 7. What are we doing to x? You ask yourself, what do we do to x? Well, look at the x and there's a 7 in front of it. We multiplied by 7. What's the opposite of multiply by 7? Divide by 7 on both sides. Once again, you got to get this thing balanced. If your hands look like this, if the teeter-totter looks like this, does that look balanced to you? Well, now does it look balanced? Yes, it does. And if you take the 7 and divide it on both sides, you have a balanced equation. What happens if you put it on one side? We get the rather large kid. Notice I didn't call him that other word. We got the really large kid. This kid's up in the air. If you're 30 minutes at recess in second grade, this was probably no fun for you. We don't want that. We want the balance. So if we do it to one side, we do it to both. The opposite of multiplying by 7 is dividing by 7. That's what I did here. I divided by 7 here. I divided by 7 here. 7 over 7 is 1x. 35 divided by 7 is 5. That's how you're going to work these. What can you do to a one-step equation? You can add, subtract, multiply, divide. That's all you can do. What's the opposite of add? Subtract. What's the opposite of subtract? Add. What's the opposite of divide? Multiply. And the opposite of multiply is divide. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.